Hi guys, this is Miss Gold. Today's lesson is Module 1, Lesson 3, Zero and Negative Exponents. Your outcomes for today's lesson are students know that a number raised to the 0th power is equal to 1. Students recognize the need for the definition to preserve the properties of exponents. Students know the definition of a number raised to a negative exponent. And students simplify and write equivalent expressions that contain negative exponents. The first thing I'd like you to do is to pause the video and complete the opening exercise and unpause it when you're ready to continue. So in this opening exercise, we had some pretty basic problems here. The first thing we were asked to do in 1, 2, 3, and 4 was simply to divide a number by itself. So if you think of any number divided by itself, you're always going to get 1. So 3 divided by 3 we know is 1. 101 divided by 101 is 1. So following that same idea, x representing any number, x divided by x is also going to give us 1. And likewise, if you had a power divided by that same exact power, we would still get 1. So 5 to the 8th divided by 5 to the 8th is still 1. For the next section, it asks you to simplify using the exponent laws for division. So it's the laws that we learned yesterday, and we know that when we're dividing bases, we are going to subtract the exponents. So here we would have 5 to the 8 minus 3, and that actually gives us 5 to the 5th power. For this one, we have 5 to the 8th divided by 5 to the 8th. So here we'd keep the base and subtract the exponents as well. But 8 minus 8 is going to give us 5 to the 0 power. So what do you notice about exercises 4 and 6? What you should notice here is that they're actually the same problem. That problem being 5 to the 8th divided by 5 to the 8th. So how do the two answers relate to each other? Well, we know if the problems are equal to each other, then the answers must also be equal to each other. So we can assume that 5 to the 0 power is also equal to 1. And this is really going to lead us into our rule because it works for any power. When you have any number raised to the power of 0, you will always get 1. So that brings us to our definition. For right now, we're just going to focus on positive numbers. So for any positive number x, we define x to the power of 0 equal to 1. So let's take a look at example 1. We have 9/15 times 9 to the negative 10th power times 9 to the negative 5th power. And the first thing I want you to note here is these are all the same base. And that's very important because we learned in our previous lesson that if they're not the same base, you can't apply the rules that we learned. Since these are the same base, we can apply the rule that we learned, which we know if we're multiplying bases, we're going to add the exponents. So what I'm going to do here is keep my base and add the exponents. So we would have 15 plus a negative 10 plus a negative 5. So when we add these together, if I do 15 plus a negative 10, that's really 15 minus 10, which leaves us with 5. And then 5 plus a negative 5 is 0. So this gives us 9 to the power of 0. And as we learned from our definition above, anything raised to the power of 0 is 1. Looking at the next one, we can apply our division rule here. We know that we would keep the base and subtract the exponents. So this gives us 4 to the power of 0. Times 7 to the power of 0. Well, we know 4 to the power of 0 is 1, 7 to the power of 0 is 1, and 1 times 1 is 1. We also want to take a look at negative exponents. And for this part, you might want to use a calculator so you can just kind of explore what's going on in this scenario. So if you take your calculator and you do 2 raised to the power of negative 1, you will get an answer of 0.5. Now, for the purpose of this exploration, let's actually turn that into fractions. So we know as a fraction, 0.5 is 1/2. If I take 3 and raise it to the negative 2 in my calculator, I'm going to get 0.1 repeating. And if I turn that into a fraction, I'm going to get 1/9. And my last one here, if I put 4/5 into my calculator and raise it to a -3, and I will tell you, please make sure you put that in parentheses in your calculator. Otherwise, the calculator may not identify that you're trying to raise the whole thing to the power. So we raise 4/5 to a -3 power, and we get a pretty long decimal. So let's just turn this into a fraction. And if you turn it into a fraction on your calculator, you're going to find that you get 125 over 64. And I wrote this as an improper fraction for a very specific reason. The next question asks, what is happening to the base each time? Okay, well, what we're really looking for is a pattern. So some of the things that I notice here is that we have a base of 2 here and a base of 2 here. So we know that 2 to the first power is equal to 2. If I'm looking for a similar pattern here, I notice I have a base of 3, but an answer of 9 here. Well, I do know that 3 squared is equal to 9, so there's a connection. And if we take a look at some of our numbers individually here, if we looked at those individually, 4 to the third power is equal to 64, and 5 to the third power is equal to 125. So what you should notice here is that basically what's happening is our numbers, or rather our bases, are flipping each time to make the exponent positive. So you can see here we had a -1, but it flipped to the bottom and became a positive exponent of 1. Here we had a -2, and this flipped to the bottom. So let me actually show you this one out. So we have 3 raised to the power of -2. And the idea here is that the number, or the base, is being flipped. So this would become 1 over 3. And when it flips, the -2 becomes a +2. And if we evaluate that, 3 squared gives us 9. So that gives us a final answer of 1/9, which is what they got here. Notice with the other exponents that we looked at, 64 and 125. Now these also flipped our fraction. So when we had a single number as the base, really what you're thinking is that this is over 1, and that's why there's a 1 on the top, because any whole number can be written as a fraction by putting it over 1. When it already is a fraction, what's simply happening is that those are flipping in their place. So we just want to note here that they are flipping places. So the base is being flipped. So that brings us to our definition. For any positive number x and for any positive integer n, we define x to the -n to equal 1 over x to the positive n. Note that this definition of negative exponents says x to the -1 is just basically the reciprocal 1 over x of x. So as a consequence of the definition for a positive x and all integers b, we can assume the opposite is also true. So if we have x to the -b, that is equal to 1 over x to the positive b. So notice this can work both ways. With that in mind, let's take a look at example 2. I have 5 to the -3, so the first thing I want to do is I want to make my exponent positive, so we're going to flip this. So really you have a 1 here, so this 1 goes to the top, 5 goes to the bottom, and now the 3 is positive. Now this is small enough that if you wanted to, you could evaluate this. So we could really say this is 1 over 125. With the one below that, it already is a positive, so we could rewrite it in a different way by bringing it to the top. And if we bring it to the top, that is going to change my positive exponent to a negative exponent. And 8 to the 9th, that's going to be a very big number, or rather 8 to the -9 is going to be a very small decimal, so we might as well just leave it as a negative exponent. Looking at the one below that, I want you to notice that there are actually 2 pieces to this. We have 3 times 2 to the -4. Now notice, only the base of 2 is raised to a negative power. So that is the only thing that is going to flip here. So this 1 goes to the top, and the 2 to the now +4 moves to the bottom. And what we can do here is really turn the 3 into a fraction as well, and then multiply across the top. 3 times 1 is 3. Multiply across the bottom. 1 times 2 to the 4th is 2 to the 4th. Now 2 to the 4th is fairly small, so we could actually multiply that out if we wanted to get an actual number, and that will give us 16. Let's move on to some similar situations, but with a variable. If the base is x, it just represents any non-zero number. So here, we would write this over 1, and so the 1 goes to the top, the x goes to the bottom, and then the negative 3 now becomes a positive 3 for the exponent. The next one is similar to our 1 over 8 to the 9th power. So when we take this and flip it, the x to the 9th moves to the top, but then it's going to become a negative 9. And again, in our bottom one, it is only the y that is going to have the negative power. So the y is what is going to flip. So the x still stays on the top. 1 comes to the top as well, but then the y to the now positive 4 moves to the bottom. I'd put these both over 1, and so x times 1 is x, and 1 times y to the 4th is y to the 4th. And so this is a simplified version of this.